Hi guys, greetings of the day. Myself Vijay Vardhan. Welcome to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VTU syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also click on bell icon to receive latest lectures as and when it is uploaded in my YouTube channel. Now let's start the session number 29 for the subject which is based on hydraulic circuits design. Now let us have a small introduction about the topic. A hydraulic circuit is an arrangement of hydraulic elements and devices interconnected in such a way to perform specific function within the hydraulic system. Design of hydraulic circuit is to select various elements and devices of required types, capabilities, capacitors, efficiencies so that go into the hydraulic circuit that the elements or devices carry out its intended function as desired and satisfactory. Elements and devices includes oil of certain grade and viscosity, pumps and motors of correct characteristics such as speed, displacements, efficiencies, valves, hoses, joints and connectors so that the system as a whole perform at the possible peak efficiency. The main objective of hydraulic system is to find specific and best possible solution to position, power, sequence or speed problem of any mechanical system such as machine tools, lifts, cranes or similar other mechanical or electromechanical equipments that are commonly used. Generally, the problems encountered by designer may be movement of machine tool table, machine slide, press ram, or mechanical transfer of load, etc. For instance, in a machine tool, the different events or activities involved are loading and unloading of jobs, clamping and declamping of jobs, forming operations such as machining, pressing, movement of materials, tools, etc. Each of the mentioned events or activities constitute a cycle. The designer has to synchronize all the cycles into a single cycle which is called as work cycle. To carry out this, designer has to consider the following factors. The first one, conformity to the desired function. Second one, level of performance and efficiency. Third one, safety and reliability. And last, not but the least, ultimate cost benefit. Then, the main parts of hydraulic circuits are as shown in the figure, which consists of a power packs, control elements, power devices, and in between there are some system accessories. We'll discuss each one of them. Hydraulic power pack comprises of an oil tank with oil, hydraulic pump, electric drive motor, mechanical couplings, strainers, filters, coolers, etc. It is a hydraulic power pack where the mechanical energy is converted into hydraulic energy. Coming to hydraulic control elements involve various type of control valves, electrical or electronic control or electric electronical control system to modify the energy, quantity and direction of the fluid as desired at each stage or point. Then coming to power drive unit. Power drive unit consists of such elements and devices which convert hydraulic energy imparted into the fluid at the power pack back into mechanical energy in the form of work. These power drive units may be actuators, motors, etc. Then coming to system accessories. System accessories include general elements such as hoses, pipes, fluid conductors, filters, and may also include special accessories such as accumulators, power boosters, heating and cooling systems, additional safety devices, etc. Safety or normal procedure to be adopted while designing a hydraulic circuit with respect to the valve position and linear actuator position. Henceforth, we'll have a small discussion of the valve position, The figure shows the 3 by 2, 4 by 2 and 4 by 3 DC walls, and the wall position will be always in the normal position. The normal position is that position even by chance the pump is switched on, the oil should flow to the tank instead of actuator or should flow to the port B and the rod end of the cylinder. Also, the names of the cylinders and the ports are mentioned only in the normal position. Other positions, directions are shown without naming of ports with only way inside the block. Similarly, the normal position for cylinders are retracted positions. Now let us discuss what is called as a hydraulic circuits first. All hydraulic circuits starts with a job to be carried out. The job may be include lifting of load, pulling or pushing of load, rotation of tool, clamping and declamping of jobs, etc. Therefore, the design of hydraulic circuit starts with the selection of actuator followed by other elements and devices. Then, what is called as control of cylinders? Control of cylinders mean extending and retracting the cylinder, holding the cylinder in a particular position between extension and retraction, holding the cylinder at the end, either extension or retraction, etc. Now, based on that, we are going to discuss very briefly about control of single acting cylinder. In a single acting cylinder, the extension of cylinder is due to oil pressure acting on the piston in the cylinder. Its retraction depends on whether the retraction is due to gravity or due to spring. If the retraction is due to gravity, the cylinder has to be placed vertically or inclined but not horizontal, and if the retraction is due to spring, then it can be placed in any orientation. Placing the spring return cylinder vertically, the speed of retraction is faster than when placed in any other position. One of the basic type of valve used to reverse the direction of motion in an actuator is direction control valve. Now the figure shows the control of single acting gravity retraction cylinder. Now the circuit diagram of a single acting gravity type of cylinder 3 by 2 manually actuated spring ridden DC valve was used. Initially, the DC valve will be in the normal position, that is position number 1, which you can see in the figure over here. In this position of the valve, pump port P is blocked and A is connected to T and the cylinder is in the retracted position. To raise or to extend the cylinder, the DC valve is brought to the actuated position 2 by pressing the knob manually. Henceforth, this is called as a manual actuated spring-ridden DC valve. In this position of the valve, port P is connected to port A and port T is blocked, which you can observe in the figure very clearly. This passage P to A allows the pressure oil to enter the lower side of the piston in the cylinder and extend the cylinder along with the loop. When the spool of the valve is moved to the position 1, from the port P to A is closed and the fluid in the lower side of the piston flows through port A to tank through the port T and the load moves down, that is nothing but retraction has happened. Similarly, the spring retract cylinder is controlled with the help of a 3 by 2 DC valves as shown in this figure A, B and C, where it is with respect to horizontal position. A refers to position of the valve for extension, B refers to position of valve for retraction, as well as C refers to the conventional diagram. Then coming to control of double acting cylinder using 4 by 2 DC valve. In case of a single cylinder, the extension of the cylinder is due to high pressure of the oil and retraction is due to either gravity or spring return. But in the case of a double acting cylinder, both extension and retraction of the cylinder are due to oil pressure. Now let us understand the working of this by wall positions, which you can see there are two positions mentioned, 1 and 2. Position 1 of the DC wall. In normal position of the wall, the port P is connected to B and A to T. In this position, port P is connected to the rod end to the cylinder and head end of the cylinder connected to the port A. This results in high pressure of oil flowing to the rod end and retracting the cylinder. At the same time, low pressure oil from the head end of the cylinder flows to the tank port A to T. Then coming to position 2, which you can see in the figure, when the valve is brought to the actuated position by supplying electrical power to the solenoid, port P is connected to the port A and port B is connected to port T. In this position, high pressure oil enters head end of the cylinder or cap end of the cylinder and low pressure oil flowing to tank through port B and T, resulting in extension of the cylinder. Again, when the valve is brought to the normal position, that is position 1, the cylinder is going to be retracted. Thus, the extension and retraction of double acting cylinder is achieved with the help of a 4 by 2 DC valve. So by thus, whatever the time allotted for the session has been kept to an end. Henceforth, thanks for your patience listening to the session. If you are having any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in this session. Don't forget to like, share and subscribe. Have a great day. Signing off, Vijay Tawardhan.